Now we are going to derive the equations of motion under gravity. Now we have to imagine that an object of mass m, it is falling from certain height h. Okay, we have to assume that there is no air resistance when the object is falling down. Here, the most important thing is we have to make an assumption that this downward direction, downward direction means the y axis which is drawn towards downward direction should be taken as positive y axis just for our convenience. Okay, so whenever the object is falling freely, what will happen? That one will experience the acceleration. That acceleration is purely due to gravity. Therefore, that is called as acceleration due to gravity. Are you clear? So, A can be replaced by G. Therefore, A can be replaced by G. Since it is acting towards downward direction, that is along positive y axis, now we can write the orthogonal unit vector j cap. A is equal to A vector, that is acceleration is equal to gj vector. Here why g is written? That acceleration is purely due to gravitational force. G is called acceleration due to gravity, and that is acting along the positive y axis, that is acting in the downward direction. Now we know how to separate the components. Here acceleration can be written in terms of its components: ax I cap, ay j cap plus az k cap. In that format we can write. Any doubt in this? So while writing this, what happens? Is there any component along x-axis? No component. Therefore, we can write it as 0 I cap can be written. Is there any component along z-axis? No. Therefore, 0 k cap can be written. But the only component is which one? Along y-axis, component is available. But it is in which form? That can be written in terms of g. Therefore, 0 I cap plus it can be written as gj, gj cap plus 0 k cap. Now you compare this one. A vector is equal to A vector, that is equal to, that acceleration is due to which component? Y component. Therefore, that is purely because of which one? Y component. That is equal to which one? G. So wherever ay comes, you can replace the term by g. Are you clear? So the acceleration due to gravity, that can be taken from the y component of a vector. So that is the meaning. Can you understand the meaning? So very important one. So now we are going to write the equation of motion when the body, when it is moving freely due to gravity. So at the time of free fall, we are able to write three equations of motion. How it could be written? Listen here. Whenever any body is dropped from certain height, the initial velocity is 0. Simply it is dropped, no. Therefore, initial velocity is 0. Now, I will write the first equation of motion. V is equal to u plus at. So, this is the first equation of motion. Now, I am going to write the first equation of motion for the free falling body. V is equal to, substitute 0 instead of a. Which one could be written? G can be written. Are you clear? That acceleration is purely due to gravity, no? Instead of a, substitute 0. Therefore, gt. So, finally, V will become gt. So, this is the first equation of motion for the free falling body. Understood? So, it is written. Next one is, I am going to write the second equation of motion for the free falling body. How to write? S is equal to ut plus half at square is the second equation of motion. Now S is nothing but this vertical distance. This distance is called y. Are you clear? When it travels from here to there, are you clear? That distance is called y. The vertical displacement can be called as y. Initial velocity is 0 and then plus half instead of a, substitute g, and it can be written as half gt square. So finally you will be arriving y is equal to half gt square. So this is called as second equation of motion for the free falling body. Are you clear? Now I am going to derive the third equation of motion. What is this? B square minus u square is equal to 2as is the third equation of motion that could be altered to get the equation of motion for a free falling body. B square minus initial velocity of the free falling body is 0, therefore 0 square can be written 2 instead of a. Which one must be substituted? Acceleration due to gravity g must be substituted, and then here the vertical displacement can be written as y. Are you clear? Therefore, the final equation will be v square is equal to 2gy. So this is called third equation of motion for the which one? Free falling body. Now everything can be summarized. Everything can be summarized in a comfortable form. Understood? So first equation of motion is v is equal to gt. Second equation of motion y is equal to half gt square, and the third equation of motion is which one? The third equation of motion is v square is equal to 2gh. These three are called as equation of motion for a free falling body. Understood? Here the most important assumption is when the body start to travel, by the time there is no velocity, initial velocity is 0. That is very, very important. Understood? Now we are going to derive two more equations to calculate the height, is it clear, up to which it travels. When the free falling body is dropped from certain height, here it starts its journey from here, finally it reaches the ground. The total height traveled that can be calculated by another important formula that can be obtained by this equation. What is this? Already we have derived y is equal to half gt square was already derived. Here y is nothing but you can take any displacement here. If it starts from here, even is it clear? If it comes here, this one also can be written as y. For that it may take some time t. But here, if it is travel from here to there, the total height basically is nothing but h. So by the time that is the maximum displacement. So when it travels from here to there, that y can be taken as maximum displacement h. For that we have to calculate the time taken. So when it travels from here to there, the total time taken can be called as t. Are you clear? If it is a small displacement, that can be written as y, and the respective time taken can be taken as small t. If it is a maximum displacement, that can be written as h. For that, the respective time taken can be taken as t. Now, for the complete height to travel, the y should be written as what is this? H. This is the height. Is it clear? This is the maximum distance travel from here to there. Understood? So therefore, half instead of y, h was substituted, and g can be written instead of t, t square must be written. Now from this you can calculate height. If time is known, height can be calculated. Otherwise, t can also be calculated. T square is equal to, cross multiply this, 2h divided by g. To get t square, take square root on either side, you will get the answer 2h by g. Understood? Take square root on either side, you will get the answer t is equal to square root of 2h by g. By using this, problems are there, you can work it out. Are you clear? So this is the time taken to travel from here to there. Very important expression. Like that, we are going to calculate one more expression. Here, when the journey is started here, and the journey is started, the initial velocity is taken as 0. When it travels and finally when it is going to hit the ground, that one will hit the ground with maximum velocity. Are you clear? So that maximum velocity can be calculated. That is when the body reaches the ground, the final velocity can be calculated by another expression. Which expression to be used? V square is equal to u square plus 2 gh can be written. Here u is 0. Therefore, v square is equal to 0 square plus 2gh. This formula can be written. Finally, if you want to get the velocity with which the object hits the ground, that can be calculated by take square root on either side. V square 2gh can be written in the next step. Take square root, you will get Vg. V ground means when the body strikes the ground, it will have some velocity that can be obtained by square root of 2gh. So this is the formula to calculate the velocity with which the body strikes the ground. We all are very important formulae to calculate all the factors. These are all the formulae that can be derived from equation of motion. Okay. Now we are going to derive three equations of motion when the body is thrown towards downward direction with some initial velocity. Here it is not a free fall. The body is thrown. Therefore, some initial velocity is there. This object is thrown towards downward direction. It is not falling due to gravity. It is thrown with the help of some initial velocity towards downward direction. For that, we have to derive three equations. Now, let us take the first equation. B is equal to u plus at is the equation. Here, u is there. U is not 0. Therefore, B is equal to u and A must be written as G. Are you clear? Therefore, plus GT is the formula. So, this is the first equation of motion when the body is thrown towards downward direction. The second equation of motion is S is equal to ut plus half at square is the expression. So here initial velocity is there. It is thrown with some initial velocity towards downward direction. Therefore, here instead of S, we can write the displacement as, for example, if it comes from here to there, the displacement can be taken as y, the respective time is t. Therefore, instead of S, we can write it as y, downward displacement, ut. What is this? Ut plus half acceleration due to gravity, a value is g. Therefore, gt square, y is equal to ut plus half gt square. This is the second equation of motion for the body when it is thrown towards downward direction. Now the third equation of motion is b square minus u square is equal to 2as is the expression. So here b square is there, u square is also there. Instead of 2, we will write it as it is. A can be written as g, vertical displacement can be written as y. So this is the third equation of motion. Okay, first, second, third. These three equations are nothing but equations of motion when the body is thrown in the downward direction with some initial velocity y, u. Okay, don't forget, it is not a free falling body. This is the body which is thrown towards downward direction some initial velocity. Understood? Now we are going to derive three more equations for when the body is thrown vertically upwards. Look at the coordinate system. Here, the vertical line which is drawn towards upward direction, that should be taken as positive y-axis, and the downward arrow, that should be taken as negative y-axis. Whenever any body is thrown in the upward direction, the acceleration due to gravity will be always acting towards downward direction, that is acting towards along the direction of negative y-axis. Are you clear? So therefore, since it is acting towards negative y-axis, wherever A comes, there you have to substitute minus G. Are you clear? Now we will write the equation of motion for the body when it is thrown in the vertically upward direction. Let's write the first equation. B is equal to u plus at is the first equation that could be modified. B is equal to, here the body is thrown in the upward direction, definitely some initial velocity will be there. Are you clear? Definitely some initial velocity will be there. That is very important. Understood? So the B is equal to, instead of u, you have to substitute u, and then minus gt must be written. Instead of a, you have to write minus gt. Can you understand the point? So here, this is the first equation of motion. Here, when the body reaches the peak, then only the velocity will be equal to 0. Is it clear? But in between, at any instant, some velocity will be there. This is the initial velocity with which the body is thrown. At a particular instant of time, the body will possess some initial velocity. Are you clear? When it reaches a peak, then only v must be substituted as 0. Therefore, this equation is written as a common equation at any instant of time. Let's write the second equation of motion. S is equal to ut plus half at square is the second equation of motion. Now, S, what is S? Vertical displacement from the ground. Instead of S, substitute y. Some initial velocity is given to the body. Therefore, u must be written ut plus half, instead of a, substitute minus g into t square. The next step you write u is equal to ut minus half gt square can be written. This is the second equation of motion in this case. Now we are going to derive the third equation of motion. What is this? V square minus u square is equal to 2as is the equation. V square at any instant, velocity is v. Initial velocity is also given, is equal to 2. Instead of a, substitute minus g. The vertical displacement is y. So finally the equation becomes v square minus u square is equal to minus 2gy. So in that format we can write. This one could be written in another form also. V square can be written in one side, and you can write it as u square minus 2gy. So this is also called as equation of motion. So 1, 2, 3. These three equations are called equations of motion when the body is thrown vertically upwards. Understood?